So in this video, we are going to solve a few questions based on simultaneous linear equations. Let us read the first question. The sum of the numerator and denominator of a fraction is 12. If the denominator is increased by 3, the fraction becomes 1 by 2. Find the fraction. So I will say let the numerator be x. Let the numerator be x. And the denominator be y, and the denominator be y. So the fraction is therefore x upon y. It is given that the sum of the numerator and denominator is 12. So this means x plus y is equal to 12. This is the first condition. Right, the sum is 12, and then it is said that if the denominator is increased by 3, that is keeping the numerator same, so the numerator remains x, and if the denominator is increased by 3, that is y plus 3, then the fraction becomes 1 upon 2, right? So now again I can cross multiply. This implies 2x is equal to y plus 3. And this forms my second equation now, right? So this is the second equation that I can mark. So now I need to find the values of x and y. Of course, you can use any technique that you want. I'm going to use the technique of elimination. So I have x plus y equals 12 and 2x minus y equals 3. If I add these two equations, I get 3x equal to 15. Which means x equals 5, and if x is equal to 5, substitute x equals 5 in say the first equation. I get 5 plus y is equal to 12, which implies y equals 7, and therefore the fraction can be written as the numerator is x, which is 5, and the denominator is 7. So the fraction is 5 by 7. Again, I formed the first equation using sum of the numerator and denominator is 12. So I formed the equation taking the sum of the numerator and denominator. And also I said that if the numerator is increased by 3, if the denominator is increased by 3. So I kept the numerator as is and the denominator was increased by 3. Then the fraction became half, right? So x divided by y plus 3 is equal to half. Cross multiplying, I got my second equation and I solved the two equations simultaneously. So this is how I can solve this particular problem. I'll pause for a minute before moving on to the next question. Moving on to the next question. Father's age is 3 times the sum of the ages of his 2 children. So here father's age can be one variable. So let the father's age be x years, and the sum of the ages of his 2 children, let the sum of the ages of 2 children be y years. So right now it is given that the father is 3 times the sum of their ages. So x is equal to 3 times y. That forms my first equation. So please note that y is not the individual age of those children. Y is the sum of the ages of his 2 children. Now after 5 years, the father's age, the father's age will now be, father's age becomes x plus 5. And let's see what happens to the sum of ages of the 2 children. So y is the sum of their ages. So assume that there is a child 1 and child 2. Now currently C1 plus C2 is equal to y. 5 years later, the first child's age increases by 5 and so does the age of the second child. Therefore, the sum of their ages will increase by 10 years because each child's age increases by 5 years. So after 5 years, the sum of their ages will be y plus 10, right? Adding 5 and 5 you get 10. So what is happening is, suppose the children were 10 and 12 years. Right now their sum is 22. I'm just taking an example. After 5 years, the age is going to be 15 and 17. You will notice that the sum of the age has become 32 because both the children's age has increased by 5 each. So the sum of the ages will be y plus 10. Now let's see what is the condition given. After 5 years, his age will be twice the sum of ages of his 2 children. That means x plus 5, the father's age will be 2 times the sum of the ages of the children. This is the second equation. So now we have 2 equations in x and y, and we can solve these 2 equations now. I would like to use the method of substitution. Again, in the second equation, x plus 5 is the father's age, and y plus 10 is the sum of ages of the 2 children, and it's twice. That is the condition given. The age of the father is twice the age of the sum of the ages of his 2 children. So using substitution over here will be very useful. So I will say using substitution of x equals 3y in the second equation. So what it gives me is x is 3y. So 3y plus 5 is equal to 2 times y plus 10. So this becomes 3y plus 5 is equal to 2 into y is 2y and 2 into 10 is 20. Let us rearrange the terms. So 3y minus 2y is equal to 20 minus 5, and therefore y becomes equal to 50. So that means the sum of the ages of the 2 children is 15 years right now, and therefore the father's age will be, x will be 3 times 15. So age of the father is going to be 45 years. So the age of the father is 45 years right now. I'll again pause for a few seconds before I move on to my next question. Moving on to the next question. If we add 1 to the numerator and subtract 1 from the denominator, a fraction becomes 1. It also becomes half if we only add 1 to the denominator. So again, the fraction is not known. So let the fraction be x upon y. Let the fraction be x upon y. It is known that x is the numerator and y is the denominator. So now I have to find x and y, and I will get my fraction back. if we add 1 to the numerator, so let me add 1 to the numerator and subtract 1 from the denominator, that is y minus 1, then this fraction becomes 1. So that means x plus y by y minus 1 becomes 1, which means x plus 1 is equal to y minus 1, and therefore I get x equals y minus 2. This is my first equation, right? I can mark this as my first equation. Then what is the second condition? It also becomes half if we only add 1 to the denominator. So what I mean by that is, the numerator is still x, and if we add only 1 to the denominator, that is make it y plus 1, then this particular fraction becomes half. So now if I cross multiply, over here they have said that I have not added anything or subtracted anything from the numerator. So I have maintained my numerator as x and I have added 1 to the denominator. Add 1 to the denominator, it becomes half. So cross multiplication will help me now. So 2x becomes y plus 1, which means 2x minus y is equal to 1. This is now my second equation. Now I can solve these two equations for x and y. So I have x minus y is equal to negative 2. This is from the first equation. And 2x minus y is equal to 1. This is from the second equation. When I subtract now, what happens is the signs change. So x minus 2x becomes minus x. Minus y plus y cancels. Negative 2, negative 1 becomes negative 3. Therefore, x becomes equal to 3. If x is equal to 3, now I can substitute x equal to 3 in, say, equation 1. So I get 3 equals y minus 2, which implies y is equal to 5. And therefore, I can say that, therefore, the fraction is going to be numerator, which is 3, divided by denominator, which is 5. Therefore, the fraction is 3 by 5. I will again pause for a few seconds before I move on to my next question. Moving on to the next question. Let's take a look at this question now. A 2-digit number is 4 times the sum of its digits. So let the 2-digit number be xy. Let the 2-digit number be xy. So x is in the tens place and y is in the units place. It's given that a 2-digit number is 4 times the sum of the digits. That means the value of this number, that is 10x plus y, is 4 times the sum of the digits. So I can add x plus y, and this part is the value of the number, right? Whereas x plus y is the sum of the digits. So I can now open up the bracket. So 10x plus y will be equal to 4x plus 4y, and therefore 10x minus 4x is equal to 4y minus y, which means 6x equals 3y, and therefore 2x equals y. This is one equation that I get. So let's mark this as the first equation. Now let me go ahead. The 2-digit number is also twice the product of the digits. So now let us write this particular statement. The 2-digit number, so the value of this number is 10x plus y, is 2 times the product of the digits. So this is x multiplied by y. Please note that when I write it as xy, this doesn't mean x multiplied by y. It is just the arrangement of those digits. But here I have written x into y because they are saying that it is twice the product of the digits. So I have to multiply these two digits. This is going to be my second equation. I can make a very nice substitution. So let's make a substitution. Let's substitute y equals 2x in this particular equation. So I get 10x plus y is equal to 2x. If you notice, that is my first equation. So I will substitute y as 2x. So 10 plus 2x equals 2 times x into y is again substituted as 2x. Therefore, I get 12x is equal to 2x into 2x is 4x square, and therefore the equation is 4x square minus 12x is equal to 0. I can now factorize this. This is going to be 4x multiplied by x minus 3 equals 0, which implies either x is 0 or x minus 3 is 0. So here we are using one concept from quadratic equation, which says that if product of multiple terms is 0, then one of the terms has to be a 0. Obviously 4 is not 0, which is why I have not considered 4 as 0, right? So the only way that this multiplication can be 0 is if x is 0 or x minus 3 is 0. That means x is 0 or x is equal to 3. Now let's take both cases. So case 1 is when x equals 0. If x is equal to 0, substituting in 1, substitute x equal to 0 in the first equation, I get y is also equal to 0. Therefore, the 2-digit number is 0, 0. And this is not a 2-digit number. It's actually a 1-digit number. 0 is not counted as a 2-digit number. Therefore, this particular case is not a valid case. So x equal to 0 therefore is rejected. Now let's take the case where x is equal to 3. So that's case 2 when x equals 3. Again substitute x equal to 3. Substitute x equals 3 in say the first equation. You get y is twice of x, which is 6, and therefore the number is 36. X is at the tens place, if you notice. So it is 36. Let's check if this answer satisfies our conditions. This number is 4 times the sum of the digits. The sum of the digits is 9 and 4 times 9 is 6. So yes, it satisfies the first condition. And the number is twice the product of the digits. The digits are 3 and 6. Their product is 18 and twice of 18 is 36. So the second condition is also satisfied, which means the number is the 2-digit number. The 2-digit number is therefore 36. I will again pause for a minute before I move on to my next question. Moving on to the next one. The sum of the digits of a 2-digit number is 15. So again, let us take the 2-digit number as, let the 2-digit number be xy. Please understand that in this number xy, the digits are x and y. the digits are x and y, whereas the actual value of this number is 10x plus y, because x is in the tens place and y is in the units place. So it's given that the sum of the digits is 15. That means I can say x plus y is equal to 15. This is my first condition, right? And it is also said the number obtained by reversing the order of the digits. So what is my original number? The original number is xy. Original number is xy, where x is in the tens place, y is in the units place. If I reverse the digits, so the reversed number will therefore be yx. It's given that the number obtained by reversing the digits is greater than the given number by 9. That means the number obtained by reversing the digits, is greater than the number by 9. That means number obtained by reversing the digits is yx minus, when I have to figure out by how much it is greater than, I of course subtract, right? So the reversed number is greater than the original number by 9. Please don't consider this as yx minus xy, that is y into x minus x into y. That is not the case over here. The number yx will be 10y plus x, because y is in the tens place and x is in the units place, minus xy can be written as 10x plus y is equal to 9. So opening up the brackets, 10y plus x minus 10x minus y is equal to 9, which means 10y minus y will be 9y and x minus 10x will be minus 9x is equal to 9. Dividing throughout by 9, I get y minus x equals 1. So this is my second equation now. Again, please notice that when they said that the number is greater, I actually had to find the value of both the numbers. So y is in the tens place, which is why it is 10y, and x is in the units place, which is why it is x. Then I take the number xy, x is in the tens place, so its value is 10x plus y, right? So now solving these two equations is easy. If you solve for these two equations, solving for x and y, you will get y equals 8 and x equals 7, and therefore the given number is therefore xy, which is 78, where x is in the tens place and 8 is in the units place. If you quickly check, the sum of the digits is 15. Please check. 7 plus 8 is indeed 15. If you reverse the number, you get 87, and 87 is indeed more than 78 by 9. So it satisfies the second condition as well, and therefore our solution is correct. I will again pause for a couple of seconds before I move on. Moving on to the next question. The numerator of a fraction is 4 less than the denominator. So again, let us assign variables for numerator and denominator. I will say let the fraction let the fraction be x by y, x divided by y, where x is the numerator and y is the denominator. So this is the numerator and this is the denominator. It is given that the numerator is 4 less than the denominator. That means the numerator is 4 less than the denominator. This is my first equation, correct? Then if the numerator is decreased by 2, so when I say numerator is decreased by 2, right now the numerator is x, this numerator is decreased by 2 and the denominator is increased by 1, that is y plus 1. Then the denominator is 8 times the numerator. So this is my modified numerator. This is my modified numerator and this is my modified denominator, right? So now it's given that the denominator is 8 times the numerator. So the denominator is 8 times the numerator. So this becomes y plus 1 is 8x minus 16, which means y is 8x minus 17. This is my second equation now. So what I did here was I said that this is my modified numerator. The modified denominator is 8 times the modified numerator. That means y plus 1 is the modified denominator. It is 8 times the modified numerator, right? So that is how I frame this particular equation. Now it's quite easy to solve these two equations. I can simply substitute. I can say let's substitute x equals y minus 4 in the second equation. So I get y equals 8 times x. X is y minus 4 minus 17. So y is equal to 8y minus 32 minus 17, or negative 7y is negative 49, which means y equals 7. If y is equal to 7, then x will be 7 minus 4, which is equal to 3. And therefore, I can say that the original fraction is x upon y. This is my original fraction. So again, I'm going to pause for a minute before I move on to my next question. Moving on to the next one. A lending library has a fixed charge for the first 3 days and an additional charge for each day thereafter. That means this particular library has a policy where for the first 3 days there is a fixed charge that you have to pay. So I will assign the variables. Let the fixed charge for the first 3 days be X, and an additional charge for each day thereafter. So let the additional charge for each day thereafter be Y. Okay. Now Sarita paid rupees 27 for a book kept for 7 days. That means Sarita kept the book for 7 days. So let us write this here. Sarita kept the book for 7 days. So for 7 days, what charges would she pay? For the first 3 days, the charges are fixed. So she is going to pay X rupees for the first 3 days. And then she totally borrowed it for 7 days. That means the remaining days are now only 4 days, right? So this is 4 days, and in those 4 days she has paid Y rupees per day. That means the total money that she paid would be X plus 4 times Y, because X is the fixed charge for 3 days. So X is not the charge per day. For the first 3 days the charge is X. Whether you borrow the book for just 1 day or for 2 days or for 3 days, you have to pay X rupees. So that is fixed. Now beyond that, for 4 days she will be charged 4Y. So we can say that X plus 4Y is equal to rupees 27. Let's read on. And Susie paid rupees 21 for 5 days. So there's second person who has paid 21 rupees for 5 days. So for 5 days, let's see what she will pay. She will pay X rupees for the first 3 days, and now out of the 5 days, 3 days are counted, so only 2 days are remaining. So therefore the total charge that Susie pays is X plus 2 times Y, which is equal to 21, right? That's the charge. Now you have to find the fixed charge and the charge for each extra day. So these are your two simultaneous equations. You can definitely solve for these simultaneous equations. If you solve for X, I believe you will get X equals 15 and Y equals 3. That means 15 rupees is the fixed charge for the first 3 days. Rupees 15 is the fixed charge for the first 3 days. And rupees 3 is the charge per day, for each day thereafter. So can we quickly check? Consider the first person, Sarita. She would pay 15 rupees plus 12 rupees because there are 4 more days. So 4 3s are 12 plus 15 is 27. That satisfies. And Susie would pay 3 2s are 6 because she has borrowed it for 2 extra days. So 3 2s are 6, 6 plus 15 is 21. That matches the given condition. And hence our solution is right. So again pausing for a minute before I move on to my next question. Moving on to the next question. Okay, let us take a look at this question. Reena has pens and pencils which are together 40 in number. So let's assign the variables for pens and pencils. Let the number of pens be x and the number of pencils be y. So the total number of pens and pencils are 40. That means the first equation is x plus y equals 40. This is the first equation. Now let's see what else is given. If she had 5 more pencils and 5 less pens. So let's make a nice table out of this. So right now she has x pens and y pencils. According to the given condition, if she had 5 more pencils, so 5 more pencils mean the pencils are y plus 5, and 5 less pens. 5 less pens means the pens are x minus 5, right? So this is the new condition that is given. Now let's see what they have stated. So this is the number of pens and this is the number of pencils. The number of pencils would become 4 times the number of pens. So the number of pencils would become 4 times the number of pens. So the number of pencils would be 4 times the number of pens. What is the number of pencils after modification? It is y plus 5. Is going to be 4 times the number of pens after modification is x minus 5. Quickly rearranging the terms, y plus 5 is 4x minus 20, which means 4x minus y is 25. This is my second equation now. Now again solving for these two equations, I get, if I add the two equations, I will get 5x is 65, which means x is 13 and therefore y would be 27, right? And therefore I can say that the number of pens is 13 and the number of pencils is 27. A quick check, the total number of pens and pencils is 40. That's great. It satisfies the first condition. If she had 5 more pencils, that is instead of 27, assume that she had 32 pencils and 5 less pens, that is 8 pens, then the number of pencils is 4 times the number of pens. That's also being satisfied, hence our solution is absolutely correct. So pausing for a minute before I move on. Moving on to the next question. Susan invested a certain amount of money in 2 schemes A and B, which offer interest at rate of 8% per annum and 9% per annum respectively. She received rupees 1860 as the annual interest. So 1860 is basically her total simple interest obtained from both these schemes. However, had she interchanged the amounts of investments in the 2 schemes, she would have received 20 rupees more as her annual interest. That means instead of receiving 1860, she would have received 1880 as the annual interest. How much money did she invest in each scheme? So let us assign the variables quickly. Let her invest rupees X in scheme A, and rupees Y in scheme B. Now let's see what is given. 8% in scheme A, so 8% in scheme A, and 9% in scheme B, so plus 9% in scheme B will give you 1860 as your interest. Whereas if you interchange the amounts, that is, now you invest B at 8%, so 8% in B plus 9% in A, this yields rupees 20 more as the interest, so it is 1880. I know that simple interest is given by P into R into T divided by 100. In this case, the time is 1 year, so we can say T is equal to 1. Therefore, the simple interest in A at 8% would be 8 into X divided by 100. 8 is the rate, X is the principal, time is 1, plus 9% in B, so that would be 9 upon 100 times Y is equal to 1860. Don't try to simplify 8 and 100, just take the LCM as 100, shift it to the other side. So you get 8x plus 9y is equal to 1860 followed by 2 zeros. This is therefore my first equation. Now if that's the case, let us now form the second equation. So in the second equation I have 8% in B, that is 8 into y upon 100, plus 9% in A, that is 9 into x upon 100 is equal to 1880. Again, don't try to simplify 8 and 100, simply take the LCM. So you get 8y plus 9x is equal to 1880 followed by 2 zeros. This forms my second equation. Now it is very much possible to find the values of x and y. I noticed that the coefficients of x and y are swapped. Therefore, the technique of adding and subtracting the two equations will help me. So let us write the two equations first. So 8x plus 9y is 186,000 and 9x plus 8y is 188,000. Let us add these two equations. So when I add these two equations, I basically get 17x plus 17y is equal to 000 and this is 374. Dividing by 17 throughout, I get x plus y is equal to 17 2s are 34, 3 remains 34. So x plus y is equal to 22,000. This is my third equation. Now again let me go ahead and subtract these two equations. When I subtract the equation, I get 8x minus 9x is minus x, 9y minus 8y is y, and 186 minus 188,000 is minus 2,000. So this is going to be my fourth equation. I can now definitely solve for x and y. Instead of using equations 1 and 2, which are quite cumbersome, I can simply solve equations 3 and 4. They are much simpler to solve. So if I solve these two, I will get x equals 12,000 and y equals 10,000. Therefore, the investments made in the two schemes A and B are 12,000 and 10,000 respectively. So if I were to write the answer, I would write it as follows. So this is how I would write the answer in the statement format. I will just pause for a minute so that you can take a look at the solution, and then I will move on to my next question. Moving on to the next question now. Jamila sold a table and a chair for rupees 1050, making a profit of 10% on the table, 10% on the table and 25% on the chair. So what we are saying is there was a table and chair. A 10% profit was made on table, and 25% profit was made on chair, and the selling price in this case was rupees 1050. If she made a 25% profit on the table, that is 25% profit was made on the table and 10% profit was made on the chair, 10% on chair, then she would have got rupees 1065. So please keep in mind these values are not the profit. They are the actual money that she receives, which is basically the selling price. So I am going to assign the variables for the cost price. So I will say let T be the cost price of the table and let C be the cost price of the chair. Now if I make 10% profit on table, if I make 10% profit on table, I know that the selling price will be the cost price plus the profit percent, that is 10% of the cost price, which is T, right? So the formula that I am using here right now is selling price is basically cost price plus the profit, which is profit percent of the cost price. This is going to be the main formula that will help me solve this particular question. Therefore, this becomes, if I were to simplify this, this becomes T plus 10% of T, and this can be written as 110T upon 100 after taking the LCM. Of course, I don't want to reduce this right now, or if you want to reduce, 0 cancels, so this becomes 11T upon 10. Similarly, if I make a 25% profit on the table, then the selling price would be T plus 25% of T. So that's going to be T plus 25T upon 100. 25 and 100 cancel 4 times, so this becomes T plus T by 4. On finding the LCM, this becomes 5T by 4. Now if I make a 10% profit, if I make 10% profit on the chair, the selling price of the chair would be the cost price plus the profit percent of the cost price. So this becomes C plus C by 10, which is basically 11C by 10. And now if I make 25% profit on the chair, then the selling price is going to be C plus 25% of C, which is C plus 25C upon 100, and 25 and 100 cancel by 25, so this becomes C plus C by 4, which is 5C by 4. Now let's take a look at the condition. 10% profit on table, that's going to be 11E upon 10 plus 25% profit on chair will be 5C by 4. This is equal to 1050. That's my first equation. And 25% profit on table, that's 5T upon 4 plus 10% profit on chair is going to be 11C by 10. This is equal to 1065, which is the second equation. So now we need to go ahead and solve for these two equations. Again, finding the LCM of 10 and 4 is 20. So let's multiply throughout by 20. When I multiply throughout by 20, I am going to get the following equations. 22t plus 25c is equal to, this multiplied by 20 will give me 21000, and again this LCM of 4 and 10 is again 20, so multiplying by 20 I get 25t plus 22c is equal to, multiplying this by 20, so 1065 multiplied by 20 is going to give me 21300. So these are my equations 3 and 4 which I can solve for t and c. I am going to pause for a minute and let you take a look at these equations, and then I will solve for c and t. Okay, so let me create some space for solving this particular question now. So I have 22t plus 25c is equal to 21000, and 25t plus 22c is equal to 21300. Let's add these two equations. I get 47t plus 47c is equal to 42300. Dividing by 47 throughout, I get t plus c is equal to 900. This is my first equation. I was again able to use this strategy because the coefficients were swapped in this particular equation. And let's subtract the two equations. So 22t minus 25t will be minus 3t, and 25c minus 22c will be 3c is equal to negative 300, which means minus t plus c is minus 100. So now if you solve for t and c, you can use equations 5 and 6 to solve for t and c. I will get t is 500 and c is equal to 400, which means the cost price of the table is rupees 500, and the cost price of the chair is rupees 400. So these answers match the given conditions, and hence our solution is right. Now of course you will have to check whether they match the given conditions or not. You can easily do that. Assume that I want to make 10% profit on my table. So 10% of 500 is 50. So my table is being sold for 550, plus making a 25% profit on chair. So chair is at 400. The profit is 25% of 400, which is 100 rupees. So this is going to be 500. This equals 1050, which is the first condition. Whereas if I make 25% profit on the table, so 25% of 500 is 125. So the selling price would be 625, plus 10% profit on the chair is going to make it 440. So if you add these two, you get 1065, which matches our second condition, and hence our solution is right. So we conclude today's session over here. I will pause for a couple of minutes before I close this particular window. Concluding today's session,